Jill charges a base rate of $25 per lawn plus $18 for each hour she mows the lawn. Which equation gives the amount of money M Jill earns from mowing a lawn for H hours? And it gives us 4 equations to choose from. So when we have these word problems, it's good to kind of underline the key points. It was 25 for every lawn, plus, and that plus means addition is going to happen, 18 for each hour she mows the lawn. And then the M represents money, H hours. So you're saying B, and that is correct. The 18 for each hour, so the 18 goes with H because it was related to hours, and since we had plus, it was 18H plus the 25. Good. Okay, this one's more of a geometry question. In which figure is the measure of angle 1 equal to 45 degrees? I'm going to have to zoom out just a little bit so we can see the whole thing. So we want it to equal 45. Okay, so if you have a copy, then you can see D is correct. Are there any of the pictures that you have a question on how you would find the angle? Like, do you have a question how to find angle 1 here or angle 1 here? Or are you comfortable on that one? Okay, so how would you find the angle? So you were correct. D is the correct answer. Each one has a different way to find the angle itself. So question A is on a straight line. And when it's on a straight line, it should all add up to 180. A lot of the times in geometry, things will add up to 180. It's a repeating pattern that happens a lot. So if you're given parts of it and one part's missing, you can add up the parts you were given, 45 plus 45, and subtract that from 180 to get the piece that's missing. So for A, number 1 is actually 90. For B, then you'll see these marks here. This means the lines are parallel. And when the lines are parallel, you basically have 2 options. Either the angles are going to be the same, either angle 1 is 145, or it also adds to 180. So when I look at it, I look to see, well, how far apart angles are basically, if you rotated a line, how far apart is it from the original line? So that one's kind of a big, wide angle, and one is small. So they're definitely not the same, which means this one is another subtract from 180. And it's close, but instead of being 45, it's 35. And then C is another straight line, which means C is also 180. It happens a lot. A lot of them use 180. So that one's also 35. The last one has this mark here, which means 90. So instead of 180, at this point you use 90, but it's the same idea. If you're given part of it, you take the entire amount, 90, subtract out the part we know, and that gives us angle 1 as 45 degrees. Good. Looks like you're good to go with that one. Now we have some probability. Leroy has a number cube with sides labeled 1 through 6. He tosses the number cube 4 times. Each toss results in a 5. What is the likelihood that the next toss will result in a 5? So what do you think on this one? Or do you have any questions on what it means by number cube? Okay, you are correct, it's D, but you're not sure. So a number cube, first of all, is just a dice, if you've ever played any sort of game that involves a dice. And each side has a different number. Sometimes they have the dots, but I'm just going to put the actual numbers. And then we'd have 4, 5, 6 on the sides we can't see. So they gave you some extra information that doesn't matter to this probability. It said he tossed it each time, and every time the result was a 5. This doesn't actually matter on this problem because it doesn't say from the previous tosses, what's the next one? This one just says, what is the likelihood that the next toss will result in a 5? So probability is always what you want to happen over the total amount of possibilities. So on our number cube, total number of sides is 6. That's why the bottom of this fraction is a 6. And what we want to happen is to roll a 5. So some people would think, oh, I put 5 on top. But it's how many 5s are on the dice. On this dice, there's only one side that's a 5. So it's 1 out of 6. Some things to watch out for. If it had been a different question and it said 2 out of 6, you would have to reduce. That wouldn't show up as a possible answer. You'd have to say, well, with a fraction, what divides into the top number and also into the bottom, which in this case is a 2. Or if you're using the TI calculator, the TI-30XS, it has a fraction button. So you could do 2 fraction button 6. I think the fraction button looks like ABC, but I don't have that calculator handy. So if you did 2 ABC6 and hit equals, it would automatically reduce it for you. And 1/3 is the correct reduced fraction. So just watch out for that. Your answer may be correct, but if it's not in the correct format, it looks wrong until you reduce. So the next one is one of your free response questions. It is all online now, so you're not like writing stuff down, but you will have to like type answers in or possibly type an equation in. So this says, for lunch, Fanya drank a can of cola that had a diameter of 2 inches and a height of 5 inches. After school, she drank a can of juice that measures twice the diameter and twice the height of the can of cola. In your answer document, find the volume of each can, show your work or provide an explanation to support your answers. Determine how many times larger the volume of the juice is than the volume of the cola can. So a can is a specific math shape called a cylinder. And on your cylinder, in order to find the volume, how much you could fit inside the can, you need to know your radius and your height. Those are what we need. And we also need a specific formula. Now, technically there's a formula sheet, but from what I've heard so far, they don't label it very well. So it's good to actually have these memorized. I thought before that they'd give you a formula sheet with stuff labeled, but you may want to memorize some of these formulas in order to utilize them on the test. So it's volume equals pi r squared h. Pi stands for approximately 3.14, or most calculators have a pi button you can use. And when it's next to the letter we're multiplying, R stands for whatever number the radius is, H stands for whatever number the height is. So the question said we had a diameter of 2 and a height of 5. So this is only the cola right now. On our cola, height is 5, but diameter is all the way across the circle. And that's not what we need for the formula. The formula says to do radius. So if the diameter is all the way across and it's 2, but we need radius, how can we find the radius, which is only halfway across the circle? Or what is the radius? The diameter is 2. What is the radius? Good, 1. If you divide by 2, you cut it in half. That gives us the radius. So 1 squared then times the height of 5. When you type this in, I believe the TI calculator has the triangle button, but it could have A to the B. I'm trying to get an exponent there. If you use the built-in calculator, you would type in, there is a pi button on the built-in, so you can hit pi multiplied by 1, and then it just has an A squared. So however you can get that exponent of 2 on your calculator, you get the exponent of 2 times the 5, and we can round and just say 15.7. So the cola can has a volume of 15.7. Because it's in inches, good, it looks like you also got the same answer when you typed it in. Since it's in inches, it's inches to the 3rd power, inches cubed. When you have that little 3 above the unit, that means a volume of something. How much could you fit inside? So now we go through the whole process, and now we do the juice can. So the juice is going to use the same formula, but new numbers. We still have pi. And then what's our new radius? It says that the can of juice measures twice the diameter and twice the height. So what's our new radius and what's our new height if we're doing twice the amount? Two for the radius, good. Our radius was 1. If it's double that, now we're using 2. And then radius is always squared. Whatever number is there for radius, we put squared on it. What's our new height? Good. New height is 10. Now we go plug this into a calculator and get the decimal for it. Pi times 2 squared times 5. So you got 125.6 and I got 62.8 because I typed something in wrong. I should have changed that to a 10. So you are correct, 125.6. Technically, this time we would round to 125.7. Since it's a 6, 6, this 6 will round up to a 7 because the number next to it is bigger than, well, 5 or bigger. So 125.7. Inches cubed again. So once you've got some of your work, make sure you're answering all the questions. So it asked you to find the volume of each can. We can check that off. We did that. We're showing our work. You would have to type this in to show the work. When you're typing it, if you don't have like an equation editor, you can use this caret key. If you hit Shift 6, this means the next number immediately is an exponent. And multiply, you can use the little star key. So you may have to type in some of that stuff with your keyboard. There's one more sentence though to determine how many times larger the volume of the juice can is than the volume of the cola can. So we still have that part to answer. You've got to make sure to answer everything it wants you to answer. So what do we do with those two numbers, the 15.7 and the 125.7, in order to figure out how many times larger? Okay, subtract would help us answer how much more. It's a very similar, so you're very close because it says how many and the word larger. Because it adds the word times, instead of subtracting, we're actually going to divide. So if it said how much larger, subtract. If it says how many times larger, divide the bigger number, 125.7, divided by the smaller number, 15.7. So that's what's hard about some of these problems is there's like one word difference and it actually means do something else. 125.7 divided by 15.7 is basically 8.0 or 8. Whether you write just 8 on this or 8.0, it should be correct because they're both the same. So you may want to type a complete sentence after showing all this work. Type something like, the volume of the cola can is 15.7 inches to the third, and the volume of the juice can, it just helps to be very specific, is 125.7 inches to the third. The juice can is 8 times larger than the cola can. So some sort of complete sentence stating all the answers and what they specifically, if you just say the volume is 15.7, they'll be like, well, the volume of what? So you just have to be pretty specific to make sure they know you know what's going on. Any other questions about this problem? Okay, let's move forward then. We have some scientific notation. A virus measures 0.0000022 millimeters in length. MM stands for millimeter. Which value expresses the length of the virus in scientific notation? So what do you think on this one? Good, B is correct. Just to point out, it's not necessarily the number of zeros. There are 5 zeros written. You're counting, we want the decimal always after the first number that's not a 0. So you're counting from where the decimal starts to where it finishes. And that's why it's a 5, not because there were 5 zeros. Good. This net is folded to produce a 3-dimensional object. So a net is if you took a 3D shape and like sliced on its edges and laid it out flat. So we just want to compare which object will this net produce. And this one is usually, you're just trying to look and make sure the shapes that are drawn on the net end up in the correct order. Good, A is correct. We have to have a square next to a circle. It kind of goes around. At the beginning of the day, the owner of a restaurant opens a new case of takeout boxes. One case holds 500 takeout boxes. There's some important information. He uses, that's actually a key word, using implies they're being taken away, an average of 35 takeout boxes each day. So each day, that means 35 should go with some version of D for day. So you have selected A, and that is correct. The 35 goes with D for day. Using implies the subtraction, and he had originally started with 500. Good. Okay. Here's some more geometry. The diagram shows a hexagon. Hexagon means a six-sided shape drawn inside a rectangle. What is the area of the hexagon? Yes, this is a tricky problem. It looks really funky. So a lot of people have trouble with it. So with this, the formula for the area of a hexagon is really, really tough. So you split it into shapes you do know the formulas for. You can do the shapes they already have these lines for. You can do a small triangle here, or you could do this entire triangle. But you're going to find each individual shape's area, and once you have those, you add them together. And the way this is drawn, all the triangle shapes would be the same, so we really only need to find one triangle and use it 4 times, and one square and use it 4 times. So do you know what the formula is for the area of a triangle? Let's start with the triangle. Okay, so this is another formula you probably are going to have memorized. Like I said, I think the formula sheet is not labeled well, so it might be on there, but you have to recognize this is specifically for a triangle. So a rectangle is base times height. That would give you the entire space inside a rectangle. If we cut our rectangle in half, that's where you get your triangle from. So a rectangle is just base times height, and a triangle is half of that, 1/2 base times height. So when we look at our triangle, the base would be this line here at the bottom. So what is the base of that triangle and what's the height of the triangle? What numbers are we going to use inside that formula? Good, 3 and 2, perfect. Even though they wrote the 3 up here, this is the same length as the bottom part. So 3 and 2. So we're doing 1/2 times 3 times 2. And when you plug that into your calculator, it will come out as 3. You can either use the fraction button, or you can literally type in 1 divided by 2. This online calculator, when you type divide, it turns it into a fraction. And then you have to click next to it to do times 3 times 2. So that area is 3. And since all the triangles are the same size, all of them are 3. So then the square is a 3 by 3 square. So what's the area of the square? And square uses the same area formula as rectangle. We can just do base times height. And so do parallelograms. Parallelograms also use base times height. Okay, so you're going to do the entire rectangle. You say 6 and 3, which works for this entire space. So 6 multiplied by 3 is 18. So now we just add all those numbers together. 3 plus 3 plus 18 plus 3 plus 3. Once you find all the individual areas, we can just add them all together. Which is 30, and you're saying C, which is correct. Good. And notice, since it's area, you'll see centimeters squared. The squared is just saying this number is an area number versus when we had volume, it was cubed, and that's saying this is a volume number. Okay. Tanya and her friends earned extra money by mowing lawns around their neighborhood. Tanya created a table to show her earnings, or their earnings. Gives the entire table. Pedro noticed that Tanya made a mistake. His earnings were $24, not $8. How does this change affect the mean of the group's earnings? So we have to find the mean with the current numbers. Then we have to do a second time find the mean with the correct number of 24. How do we find the mean? When you find mean, which is the math word for average, how do we average that? Good. Add all the numbers, divide by how many? So we currently have 1, 2, 3, 4, 5, 6, 7, 8 numbers. When you plug it into your calculator, do the addition and get your answer. Don't just hit divide by 8 at the end, or the calculator is going to get it wrong. So you said the answer is B. That should be correct. What was the first average you got when we did all of them added together? 25, 22 plus 17 plus 8. So 24.5 was the first one. And when we change it to 24, 26.5. Okay, yep. So that is correct. The first mean was 24.5. The second was 26.5, and it increased by 2. Good. So another free response one. A pattern of shaded and unshaded squares is shown below. In your answer document, find a formula for, or describe in words, the number of squares in the nth figure. Find the number of squares in the 50th figure, show your work, or explain your answer. So for each square, we need to, or for each figure, we need the number of shaded squares. So first figure is just one shaded square. Second is 3. Third is 5. 4 is 7. And 5 is 9 shaded squares. So, do you know how to find a formula for this, or do you already have a way you would describe in words what the nth figure? The nth figure is just, if you kept going, what's a very generic, general way to figure out that random could be any figure? Maybe it's the 40th figure, maybe it's the 57th. So you said multiply by 3. Some of them could work that way. But what we're looking for is what's going on and can it continue? You could do 1 times 3 and get 3, but could you continue that pattern? Could you do 3 times 3 and that comes out 5? Because you want the pattern to continue using the same setup every time. You want it to be consistent. So times 3 only works the 1 time. You can also look for anything that is a pattern with addition. Might be multiplication, might be addition. There's lots of ways you can do a pattern. So this time we're adding 2, very good. Each time if we add 2, that gets us to the next number. So the nth term would be add 2 n times to the very first figure 1. So you could describe it in words like that. To find the nth term, add 2 n times to the original number of 1. You could also find the formula. So the formula itself is the nth term is going to equal the starting amount when you're at 0. At figure 0. Plus 2 times the figure number itself. So if we're at 0, we need a figure 0 number, which means we actually have to go backwards. If we go backwards from 1, instead of adding 2, we're subtracting because we're going in the wrong direction, which takes us to -1. So the nth term is -1 plus 2 times, and for the figure number, we're going to use the generic n for figure number. So finding the formula can be difficult. I wanted to show it to you. Sometimes it's easier to just figure out the pattern, but the actual formula itself can be helpful in finding the 50th figure. If you can find the formula, all we have to do is plug in 50 for the letter n. We'd have -1 plus 2 times 50 is 100. Sorry, that looks like a 5 because the 0 went off into the gray. And -1 plus 100 is 99. So that's why the formula is useful, but like I said, it can be hard to come up with the formula. The other tactic is to literally just write it out. For figure 1, you had a 1. For figure 2, you had 3. For figure 3, you had 5. And continue that table until you get to 50, which is very time consuming, but it can be done. So any more questions on this problem? It is another kind of difficult one because getting that formula can be so difficult. Okay, how to explain the answer. So, do you prefer the just verbal explanation, or do you prefer the actual formula? Which one would you want me to clarify? The verbal. Okay. So the verbal, I'm going to get rid of all this stuff here. So the verbal itself would be this sentence here. Sorry, this one. So to find the nth term, add 2 n times to the original number of 1. So the nth term is this number. Each of these are the terms. And n means we don't know what term they want you to ask for. N is just the generic. You could be looking, you know, if they said the third term has a value of 5. The fifth term has a value of 9. So that's why we use those words nth term, because they said the nth figure. Add 2 n times. So the n times is because if you're only getting to the second term, you added 2 one time. But if you're getting to the third term, you had to do 1 plus 2 plus 2. You had to add it 2 times. And if you're getting the third term, you had to start at 1 and add 2 3 times. So that's why we're saying n times, because whatever figure they're asking for, that's the number of times you add the number 2. So then using the verbal, if we're adding it to the original number of 1, when they ask for the 50th figure, instead of creating a whole table, one more option is to do 2 times 50, because we said we're adding to n times, and they specified using 50 as the number n in this second sentence. And then we add that to the original number of 1. Maybe my verbal explanation is actually not accurate, or how I'm using it is not accurate. Add to n times the original number of 1. I might not try and use the verbal explanation because we're going to be a little bit off. So after creating the verbal explanation, that should be enough to get the points for the verbal. I would show your table. I would use the table and say, using a table, I found the 50th term is 99. That was our answer when we used that formula. So the verbal description here is good enough, but I would create that table and keep adding to. Sorry, I wrote 5 when I should have gone up to 4. The fourth figure is 7. The fifth figure, if we add 2 more, is 9. The sixth figure, if we add 2 more, is 11. And I would just literally create this table until you get up to the 50th figure to get your accurate number at that 50th figure. Any other questions on this problem? Okay. So another geometry type question. The geometry ones can be difficult just because you see the algebra so much more than you see the geometry. So trapezoid, RSTU, is shown on the grid. So when it says RSTU, it's just talking about these actual points. Which graph shows the image of the trapezoid after it is translated 5 units up and 3 units to the left? So translation just means a slide. You basically count each one of your points, 5 up and 3 left. So if we start at like point S, I just go point by point and count 5 up, 3 left. When you count, the where you start is actually 0. We don't say 1, 2. We say this is where I'm starting. Once I've made a move to the next line, that's 1, 2, 3, 4, 5, left 3. It looks like you've already said the answer is A, which is correct. You'll notice a little apostrophes. That just means the new S. The point we found here originally was S, but now that we've moved it, we call it S prime. And good, it literally is just counting. 5 up, 3 left. Number 19, 4 numbers are shown. 31 over 4, 7 and 5/8, square root of 50, 7.82, which shows these numbers ordered from least to greatest. So when you do a problem like this, it's best to get the decimal version of each number. So for 31 over 4, you would want to do 31 divided by 4. If you use that fraction button, it's just going to leave it as a fraction, or it might change it to the mixed number. We would just want 31 divided by 4, which is 7.75. Then the 7 and 5/8, looks like you've already picked an answer of C. I don't know without the decimals, so I'm going to get them really quick. 7 and 5/8, we just need the 5/8 in the calculator to get that decimal. It is 0.625, so that would be 7.625. And then square root of 50 is the check mark button and the 50. 7.07, we don't need to write the entire thing down. We just need to be able to compare it. And so the last one was 7.82, already a decimal. So the square root of 50 is first. That's number 1, so B or C. And then next is 7.625, which is the 7 and 5/8. So yes, you were correct. Good. So number 20, Zach is packing for a trip to Scotland. He read that the average temperature in the summer is 18 degrees Celsius. C stands for Celsius during the day and 7 degrees during the night. What is the difference between the high and low temperatures in degrees Fahrenheit? So since we're in Celsius, first we have to convert to Fahrenheit. And then when it says the word difference, we're going to subtract. So when we find it in degrees Fahrenheit, all we do is replace the letter C, first with the 18, then with the 7 to get our 2 Fahrenheit numbers. So we have 9 divided by 5 multiplied by 18 plus 32. Our first one is 64.4 Fahrenheit. And then we do it again, but now we have 9 divided by 5 times 7 plus the 32, which is 44.6. You're saying the answer is A. You are probably correct. We just need the difference. 64.4 minus 44.6 is 19.8. Good. You are correct. I think we have time for one more. I have another meeting after this, so I need to be done by 1:55 Utah time. A grocery store has a triangular pyramid of soup cans on display. Stephen counts the number of cans in each of the top 5 layers. Each successive layer continues following the same pattern. The display has 10 layers. How many cans are in the 10th layer? So this one does have a pattern. Our other pattern was the same every time. This one's going to be a different number every time, but there's going to be a pattern to that pattern. So it's kind of weird because you have to find a pattern within a pattern. And a lot of the times it's either going to be addition, subtraction, or multiplication. One of those is our pattern. So when we go from 1 to 3, if it's addition, I almost always start by checking addition. So if it's addition, we add 2. From 3 to 6, we add 3. From 6 to 10, we add 4. And from 10 to 15, we add 5. Now, it's not consistent, but it's consistent in that each number is going up by 1. First, we added 2, then 3, then 4, then 5. Next, we're going to add 6, and after that, 7, and after that, 8. So we had to find a pattern for that pattern. If you tried multiply, it would not have a pattern to the pattern even, so you couldn't end up using it. So this one, I literally would just continue the table and say, okay, the 6th layer, we're adding 6 to the 15. So it's 21. So you said D. I think you're right. 7, 8, 9, 10. We want the 10th layer. We add 7. Then we add 8. And then we add 9. And then we add 10. So you are correct. 55 is the correct answer. So we are out of time for today.